Okay, so this is how to find the empirical formula from a combustion reaction. So what we've got in this problem, we've got an organic compound, and it consists of, let me get my lightsaber out here, carbon, hydrogen, and oxygen, but we don't know how much, but we do know we have 10 grams of that compound. We burn it with oxygen, and it produces 14.43, and we also produce 7.38 grams of water. Okay, so now in this problem, ultimately what we're trying to do is we're trying to find out the ratio of carbon to hydrogen to oxygen. Now, if you remember when we did empirical formula originally, what we did was we had 3 easy steps. We took grams and converted to moles, then we divided by the least number of moles, and then we rounded. The problem is we need grams of carbon, grams of hydrogen, and grams of oxygen. So here's what we can do to find that. Like I said, a little trick to finding out, we're going to do grams of carbon first. If we look at this, okay, we know, let me switch to red. We know that we produce from our given, we produce 14.43 grams of carbon dioxide. What we need to know is how much of that 14.43 grams is just carbon. Okay, and we can do the same thing here. How much of this water, the 7.38 grams of this water, is just hydrogen? Okay, if we know that, then we'll have carbon, hydrogen, and then I'll show you how to figure out oxygen in just a minute. So basically, what percent of carbon dioxide is just carbon? Well, what we need to do is we need to find the percent composition of carbon. So carbon weighs 12 grams, and carbon dioxide, the entire molecule, weighs 44. That means of every carbon dioxide sample, 27.3% of it is carbon. So what we'll do in just a second is we'll multiply. So we'll multiply 27.3% by the 14.43 grams. Okay. And we'll do the same thing for water. So of every water sample, 2 grams of it is hydrogen, and divided by the total of 18 grams. That means every water sample, 11.1% of it is hydrogen. So if we multiply 11.1% by that, that'll give us the grams of hydrogen in there. Okay, so knowing that every single carbon dioxide molecule, 27.3% of it is hydrogen, we're going to multiply that down here by our 14.43 grams. That means of the original 10 grams, 3.94 of it are carbon. Take our percent composition of hydrogen water, multiply it by how much water we have. That means of our original 10 gram sample, 0.819 grams of it are hydrogen. Okay, so we have 10 grams total. Well, we know how much of that's carbon, how much of that's hydrogen, how much of that would be oxygen. Well, whatever's left over from the 10 grams is going to be oxygen. So 10 grams minus our carbon minus our hydrogen is going to give us 5.24 grams of oxygen. So now we're in familiar territory. We have grams of each element, so what we need to do is convert grams of each element to moles and then divide by the least number of moles. So that's what we're going to do here. Take our 3.94 grams of carbon, divide it by its molar mass. That gives us moles of carbon. Do the same thing for hydrogen, divide it by its molar mass. Notice hydrogen is just 1 gram. Okay. That means we have 0.819 moles of hydrogen. Do the same thing, grams of oxygen divided by its molar mass. And then what do we do next? Well, we divide each by the least number of moles. So if we look down here on the bottom, I already did that. That means we have a ratio of 1 carbon to 2.5 hydrogen to 1 oxygen. Well, what are we going to do so that each of those are whole numbers? We're going to multiply each of these by 2. Okay, so if we multiply each of those by 2, that gives us C2H5O2. And that's how you're going to find the empirical formula through the combustion of an organic compound. Okay, so really the only new step is this one right here, finding the percent composition of carbon in CO2, finding the percent composition of hydrogen in H2O.